session. I'm really glad that you guys all came out. I see some new faces in the group, and that's really good. I hope you guys find what you're looking for. Before we get started, our friend Haley was talking to me, and she has a question that she wanted to ask you guys, get some group advice. So, Haley, go ahead.
Hi, everyone. My name's Haley.
Hi,
Haley. I've been going out a lot with my friends on the weekends for drinks, and I keep finding myself making bad decisions. Every time I go party, I have a different number of drinks, as well as a different kind of drinks. I want to keep partying with my friends, but I want to stop making stupid decisions. I've heard there's a certain number of drinks you can have before your judgment is impaired. I've also heard certain types of alcohol, like vodka or tequila, can make people act differently. Can you guys help me find a way to figure out if there's a number of drinks I'm having, or the types of drinks I'm having, or both, that are causing me to embarrass myself? Please help me.
Well, I have a suggestion. So the first thing, I think it's generally a good idea to do this thing called hypothesis testing. So the first thing you do is you figure out what your question is. Obviously, your question is you're wondering how many drinks you're having and whether or not that's leading you to bad decisions. So then you have to figure out what the opposite of that is, which is a bad decision or not resulting from your amount of drinks. And once you do that, then that's basically setting up your situation. So from there, you figure out what your average amount of drinks are that lead you to bad decisions, and then your average amount of drinks that don't lead you to bad decisions. And then you can take those two means and figure out really if it's the amount of drinks that lead to the bad decisions, or if you're just making bad decisions in general. And this sort of testing can be used on many different types of tests that I think they might have some to say about that.
Hi, Haley. So in order to solve your alcohol situation, the t-test dependent variable suggests that we measure two different scores to solve the number of drinks you can have before your judgment is impaired. We will first measure your judgment before and after each drink to determine how much alcohol you should consume.
Hey, Haley. How about we find the average of drinks a person can have? Standard deviation. How about we find the average of drinks a person can have before their decision making is effective? Let's find out the variability and how spread out different scores are, since the average could be misleading. First, we should subtract the amount of drinks you have by the mean square deviation, add up all the square deviations, and lastly divide by the number of scores. You take the square root of the variance to get the standard deviation, or more precise, average. This way you can see how far away from the mean you really are.
Oh, okay. Okay. So you could run an F test to compare how drunk you get off the different types of alcohol you like. The next couple times you go out, restrict yourself to one type of drink each time. Have all your friends do the same, switching up who is drinking which type each time. Have everyone record how inebriated they feel after each night of drinking one of the drink types you decide to look at. Your groups are the drink types you decide, and your scores come from how inebriated each person feels after a night of drinking one of the types. After you collect the data from all that, you can begin to calculate F. F is a ratio of the within group's estimate of the population variance and the between group's estimate of the population variance. The within group is estimated by combining the variance of scores from each type of alcohol. The between group is the estimated variance of the mean scores in each group. To get F, simply divide the between by the within, which should be easy when you're drunk. If you get 1, then the variances are equal.
Hi, Haley. Perhaps you could use a chi-square test in order to compare your expectations of the association between the types of alcohol you're drinking to the bad decisions you're making, and compare those to the actual observed correlation between the two variables. Possible combinations of drinks would be beer, hard liquor, wine, or champagne, and bad decisions might be coming home too late before school, drinking and driving, or forgetting work and school assignments. So you could create expected values for a certain total of these associations or ratios, so let us say like 30 instances. Like beer will cause you to avoid schoolwork, or hard liquor will cause you to drink and drive more. You should most likely distribute your expected values evenly, since it's reasonable to assume that there's an equal chance for any occurrence. Once you have those expected values, you can create a contingency table to determine the actual observed values and compare those to your expected values. This is information you would need to calculate the likelihood of the two variables making bad decisions and types of alcohol or all of the differences of the expected values minus the observed values, square those, and divide by the expected values. Once you get that value, you can determine your degrees of freedom by taking the number of rows minus 1 times the number of the columns minus 1, which would be 2 minus 1 times 3 minus 1, which is 2. With the chi-square value and your degrees of freedom, you can look up a p-value on a table, which is the likelihood that your null hypothesis, which says that the two variables are independent or due to chance, is true, and you will get a percentage out of that test.
Hey Haley, you can also try using ANOVA, which lets you test the variation among the means of 3 or more groups. Your populations can consist of 2 or more of your friends going out and drinking. Each person limits themselves to 1 drink that is different from one another. You can record the overall difference each drink has made on each person to see what kind of alcohol affects you more. Once you find the data, you can find the within groups estimate of population variance and the between groups estimate of population variance and conduct a t-test.
Hey, you can also run an independent t-test. On the course of 1 week, for example, restrain yourself from drinking, and that will be your control set of data. On the following week, go out and drink like you normally do, and that will be, and I'll try and keep record of how many drinks you're having per night. This will be your experimental set of data. Once you have your data, run your t-test using the 5-step procedure of hypothesis testing that Ron explained. And then make sure you calculate the standard deviation of the distribution of differences between means, and then calculate your t-score. Once you do that, compare your sample t-score to your cutoff scores, and decide whether you should reject your null hypothesis or not. This procedure should tell you if it's the number of drinks you're consuming that is causing you to make bad decisions.
Hi Amy, the suggestion I have would be find the z-score. By doing this, it will tell you if the number of drinks you are having is above or below the average number of drinks. To find this, you will need the mean and the standard deviation in order to change your score, which is the number of drinks you have on a night out, to a z-score. To change it to a z-score, you would subtract the mean from your score and then divide by the standard deviation. This number will then tell you where your alcohol intake falls on the distribution of z-scores.
Another suggestion is that you could check the association between the amount of drinks you have and how impaired your judgment is to see how many drinks you should limit yourself to. To do this, you would have to figure the correlation between the 2 variables. To find your correlation, we would first have to change all the scores to z-scores by subtracting the mean from the score and dividing that by the standard deviation. We would then create a scatter diagram by plotting a point for each pair of scores. Using the diagram we've created, we can see just how many drinks is too many.
Thanks, guys.
Now, hold on, you guys. You gotta think, why are we all here? Because alcohol is bad. And so not only did I not expect this question, but I didn't expect this kind of response from you guys. You guys are telling her how many drinks to drink is okay, but I think the focus is that all drinking is bad. You should never drink. And so I want you guys to take that home tonight, think about it, and I'll see you again next week. Thanks.